Hello everyone. Today we're going to be talking about metric conversions. Metric conversions is a technique where we can convert, for instance, from grams to kilograms to milligrams. It's a conversion that's based on using prefixes that are multiples of 10. Now, there are two ways that you can conduct metric conversions. In this video, I'm going to show you a way where we can just move the decimal point either to the left or to the right to make the conversions. In a future video, I will show you another method which is called dimensional analysis, which involves using conversion factors so that you can convert from one unit to the other. Now, the prefixes that we're going to be looking at are based on a power of 10, which means when you move the decimal point either to the left or to the right, you are multiplying it by a factor of 10. Now, if you look at this third slide here, the prefix multipliers are always the same regardless of the standard unit. If you're measuring length, which is in meters, versus, let's say, mass, which is in grams, the prefixes have the same value. For instance, you have centigrams or centimeters, it would be the same value. Kilograms, kilometers, kiloseconds. Again, the prefix kilo, you'll see, has the same value of 1,000. Let's take a look at these prefixes. If you look at this table, here, the largest prefix is tera, which is 10 to the 12, and the smallest is atto, which is 10 to the negative 18. Now, usually we don't have to learn those. Those are not used as often in chemistry. So what we're going to do is we're going to condense, and we want to learn from giga all the way to pico. These are the ones that we're going to be working with most often. As you can see, giga, the capital G is the symbol. Okay, mega is capital M. And the values in exponential notation are here. Gigas 10 to the 9, which is 1 billion. Megas 10 to the 6, which is a 1 million factor. And then you could see kilo is 1,000. Then you got hecto. Now notice deca and deci both begin with the letter D. But deca has two letters. Some textbooks, you might see a capital D for deca, whereas deci is a lowercase d. Deci is the smaller one. Now notice over here that there is nothing. There is no prefix. This is what we call the base unit. This depends on what you are measuring. If it's length, it would be meters. There is no prefix. If it's mass, it would be grams. If it's time, it would be seconds. So the base unit has no prefix. And then everything gets smaller. You got centi, milli. Notice deci is the equivalent of 0.1. Centi is the equivalent of 0.01. And then it keeps decreasing by a factor of 10. Notice micro uses a Greek symbol. It looks like a cursive U. And then you got nano and pico. Those are the ones that we're going to focus on. Now, I have a trick where we can write this grid instead of how you see it vertically. I'm going to show you a trick where we're going to write this horizontally. And we're going to start with giga as our largest unit, and we're going to end with pico. So, if you can, grab a piece of paper, and I would like you to turn your paper vertical so that it's long way from left to right. That way you have more room. And what I'd like you to do is, since our biggest one is giga at 10 to the 9, we'll put a G here for giga. Okay. Watch what I'm going to do. I'm going to decrease by 10 here. So you got 10 to the 9, 10 to the 8, 7, 6. This one is mega. You don't have to know the prefix for 10 to the 8 nor 10 to the 7. Then you got 10 to the 5th, 4, 3. 10 to the 3 is a very popular one. It's kilo. Okay? Then you got 10 to the 2, which is an H for hecto. These are all the names of the prefixes. Then you got 10 to the 1, which is deca. Let's put it down here. Sometimes it's written as D-E-C-A, and that is either D-A. Sometimes you'll see a capital D. Then you have what is called the base unit. There is no prefix here. Okay, so we'll make a little mark here. This is the base unit. And then we have to go smaller. So you got 10 to the negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 7, 8, 9. Now, if you can, extend this so that it goes to 10 to the negative 12. So if you can, over here where I ran out of room, go ahead and put 10 to the negative 10, negative 11, and negative 12, and extend your grid. Now, let's write the prefixes. For 10 to the negative 1, it's a D for deci. Okay, and 10 to the negative 1, basically it means 0.1. Then you got centi for 10 to the negative 2. Let me write that down here, centi. That's an E here. And then you got milli. Notice there's a capital M for mega. The lowercase m, okay, would be milli. And then you got, the nice thing is we don't need to know negative 4 nor negative 5. And then this one gets the Greek letter micro. Okay, that's a Greek symbol there. And then you don't need to know negative 7, negative 8, but you do need to know that nano is negative 9, and then negative 10 and negative 11 we can ignore. And then negative 12 would be pico. So this would be your grid. Now, value-wise, remember that, you know, giga's a billion, mega's a million, kilo is 1,000, hecto is 100. Everything's by 10. Deca, the base unit, 10 to the 0 is 1. Then you got deci, centi, okay, and then milli over here. And then it keeps getting smaller by 10. So you're going to see that this grid will allow us to make the conversions so much easier. I'm going to give you an example. Let's take a look here. Let's use a different color here. So let's say that I had 325.6, let's say, milligrams. And I wanted to convert this to centigrams. Okay? So if you look, milli is over here. You are right now at 10 to the negative 3. And I'm asking you to go to centi, which is just one spot over, right over here. So here's the beauty of this grid. To go from milli to centi, all you got to do is move the decimal point. Right now, you see it's right here. And you're in milli, and all you got to do is move one spot to the left. So what you're going to do is the same way you moved on the grid. Since I moved to the left on the grid, I'm going to move the decimal point also to the left, and I'm only going to move it one spot. So when I move it one spot, the answer becomes 32.56 centigrams. And that would be my answer for that first one. Okay? Now, let me erase over here a little bit, and let's get some clutter out of here. And I'm going to give you another problem. Okay? So let's say in my next problem, we're going from, let's say I have 0.275 milliliters, and I'm going to liters. Now notice there's no prefix here. Whenever there's no prefix, that's a base unit. So a base unit could be liters, like for volume. It could be meters for length, seconds for time, grams for mass, and so on. So in this problem, we're in milliliters. We're over here. And we want to go to liters, which is the base unit, which is over here. So we are also going to go to the left again. Now, notice the decimal point is right here. So this time, I want to move it 1, right over here to centi, 1, 2, and 3. So when I move it 1, 2, 3, here's what you got to do. The decimal point is now here. You got to fill this in with 2 zeros. And when you rewrite your answer, there's the 2 zeros you added, the original 0 from the problem, and then 275 liters. And that would be the answer. If you want to put a 0 here, that's fine. Okay? But I moved it 3 spaces to the left. Let's do a couple more problems here. Let me erase a little bit of this clutter. And notice, as a reminder, whenever you see that there is nothing, no prefix, like in this problem, the liters had no prefix, you're going towards the base unit. Okay, so here's a new problem. Let's say we got 2.45 kilograms. And we want to go to, let's say, just grams. Okay, so again, grams would be a base unit. Well, in this problem, we're over here in kilo. And we want to go all the way over here to grams. This time, we're moving in the opposite direction. We're moving to the right. So the decimal point is going to go to the right. The question is how many spaces? Well, from kilo to grams, you're going from 10 to the 3 to 10 to the 2. That's 1, 2, 3 spaces to the right. So you're going to go 1, 2, 3. Now notice you're going to have to add a 0 here. So when you rewrite your answer, it's 2,450. You could put a comma there. And it's now in grams. So that would be the answer to that problem. Okay? Let's try one more. Let me erase a little bit of the clutter here. And this way you get accustomed. Now, the way I'm teaching you how to do this is by using this grid. A lot of times I'll tell my students, before you take a test or a quiz, write this grid down. Have it on the top of your paper, so anytime you have a metric conversion, you already have this grid written down, and you could do it quickly by moving the decimal point to the left and to the right. It's a very efficient way of solving a problem. All right, let's say I had, let's say 3,215.5, and let's call this microseconds. Okay, microseconds. That's the micro symbol. And let's say I wanted to convert this to centiseconds. So the first thing you do is find where you are on the grid. Well, micro is all the way over here at 10 to the negative 6. Centi is all the way over here at 10 to the negative 2. So we are at micro and we want to go all the way to centi. So we know we're going to move the decimal point to the left. The question is how many times? Well, let's find out. We're going to go 1, 2, 3, 4. So even though we don't need to know these prefixes, there is no name for them, we do need to count them as spots. So when you're moving from micro to centi, you do need to go 1, 2, 3, 4, and you do need to count those spots. So when we move it, it'll be 1, 2, 3, 4. Now the decimal point will be in the front, so when you rewrite your answer, you're going to have 0.32155. If you want to put a 0 here, that's fine, and that's going to be centiseconds. So the nice thing about this grid is that if you set it up correctly, the way you move the decimal point on the grid, for instance, we just went from micro to centi, we were moving it to the left. The same way you move along the grid is the same way that you move the decimal point when you're actually doing the conversion. Every time you move the decimal point by a spot, what you are doing is you are moving it by a factor of 10. Okay? So what are the main mistakes that might happen that I've seen personally is, number one, I've seen students that they move the decimal point the wrong way. Just remember the way you're moving on the grid. If you're moving to the left, the decimal point will go to the left. If you're moving to the right, the decimal point will go to the right. So whichever way you're moving on the grid, the decimal point will move in the same direction. The second mistake I see is miscounting. Okay? So let's not let that happen. I'm going to give you one final example. All right? And I'm going to give you one that's a little bit more challenging. So let me erase all of this. And it is important that you count correctly. All right? And in this example, you're going to see that the base unit is also counts. Every time you move from one spot to the other, it counts by a factor of 10. So let's say that I had 415,150, so 415,150 millimeters. And I want to change this to kilometers. So we're going from millimeters, which is all the way over here, to kilometers, which is all the way over here. So we're starting over here, and we need to go that way. So we already know that we got to go to the left. Now, the decimal point right now, when you don't see it, it's written, it's here. It's understood that it's there. So we're going to move this now to the left. The question is how many times? Now, pay attention to how I do this. You are right here. So we're going to move it 1, 2, 3, 4, 5, 6. 6 spaces to the left. So 1, 2, 3, 4, 5, 6. So our new number, it's going to be here, is going to be 0.415150. We could even put the 0 here. And that will be our answer in kilometers. Okay, so make sure that when you count, when you do that, you don't miscount. You include every spot. So you're starting here, you go 1, 2, 3, 4, 5, and 6. Okay, very important. All right. In another video, I will show you how you can do a metric conversion using another technique called dimensional analysis. In this video, this technique was using this grid where we move the decimal point to the left or to the right. Okay? Hopefully, with some practice, you'll get good at doing these problems.